Hello guys, welcome back to today's maths tutorial on my YouTube channel. Today we have this exponential equation with conjugate powers. So how do we solve this kind of problem? It's an exponential equation with conjugate powers. So what we're going to do first is to, first of all, let me write down the solution. So we have 5 to the power of 3x minus 1 equal to 3 to the power of 3x plus 1. You can see clearly that the powers on both sides are conjugates. They look similar, but a difference in sign. So that is why they are conjugate, okay? So what I need to do is to apply this law here. This is the law that if I have a to the power of x plus y, then I can rewrite this to become a to the power of x times a to the power of y. That if it is positive, then if it is negative, that is a to the power of x minus y, then it becomes a to the power of x times a to the power of minus y. Okay, so I'm going to apply these two variants of the law of indices to both sides of the equation. Okay, so I'm going to have 5 to the power of 3x times 5 to the power of minus 1 equal to 3 to the power of 3x times 3 to the power of 1. Okay, so now this I can write as 1 over 5. Then I have 5 to the power of 3x times 1 over 5 equal to 3 to the power of 3x times 3. Now, the reason why 5 to the power of minus 1 becomes 1 over 5 is simply because of this simple rule of indices. If I have a to the power of minus x, that will give me 1 over a to the power of x. Okay, that's the reciprocal law. So if the power is minus 1, like for example a to the power of minus 1, then it becomes 1 over a to the power of 1. Of course, a to the power of 1 is the same thing as a, right? Okay, good. So let's continue. So on the left hand side, I'm going to have I'm going to rewrite the left hand side to look this way. 5 to the power of 3x all over 5 equal to 3 to the power of 3x times 3. Okay, so what I need to do now is to multiply both sides by 5 in order to clear the fraction on the left hand side. So I have 5 multiplied by 5 to the power of 3x all over 5 equal to 5 multiplied by 3 to the power of 3x, then multiply by 3. So this 5 on the left hand side will cancel out. So we have 5 to the power of 3x equal to 5 times 3 is 15 multiplied by 3 to the power of 3x. So what I need to do now is to make sure I have the quantities with the variable on one side. This time around, preferably on the left. So what I need to do is to divide both sides of the equation by 3 to the power of 3x. So I have 5 to the power of 3x over 3 to the power of 3x equal to 15 times 3 to the power of 3x divided by 3 to the power of 3x. So both the to the power of 3x on both sides will cancel out. So I have, so let me move over to the next page. So I have 5 to the power of 3x all over 3 to the power of 3x equal to 15. Okay, so now what I'm going to do is I'm going to apply this rule. If I have a to the power of n over b to the power of n, then because the bases, the powers are the same but different bases, you can see in the case we have power 5 here and base 5 and base 3, but the powers are both the same, so I can combine and say a over b to the power of what? N. So I'm going to apply this rule to the left hand side. So this simply becomes 5 over 3 to the power of 3x equal to 15. So then I can take, just like you can see, the bases are different on both sides. This is a whole number base, while on the left we have a fraction base. So what we need to do is to take log of both sides. Take log of both sides to base 10. So that's natural log. Just apply natural log to both sides. So we have log 5 over 3 power 3x base 10 equal to log 15 base 10. So now there's another rule that says if I have log p to the power of n base 10, then this n, power n, becomes a coefficient of the log. So you have log, so it moves to the front, and then that's behind the log here to become a coefficient. So you have n log p base 10. So this is another very important rule of logarithm that will help us to do justice to this question. So so next we have, so we move this 3x over here. So you have 3x log 5 over 3 base 10 equal to log. So now this 15, I'm going to write 15 as 5 times 3 log to base 10. So so what I need to do now is to divide both sides by log of 5 divided by 3 to base 10. So once I do that, I have 3x on the left, and then I have log. So I'm going to express this as log 5 base 10 plus log 3 base 10. So this is one of the basic laws of indices. So if I have, logarithm. So the law says if I have log p over q base a, then this becomes log, so this becomes log log p base a minus log q base a. Likewise, if you have log p times q base a, so it becomes log p base a plus log q base a. So basically I'm going to be applying these two laws to the remaining, to the next part of the solution. So I have a log 5 over 3 base 10. So I'm going to apply this law to the base, to the denominator. So I have 3x equal to log 5 base 10 plus log 3 base 10 all over log 5 base 10 minus log 3 base 10. So now log 5 log 5 base 10 is 0.699. Log 5 base 10 is 0.699. Log 3 base 10 is 0.477. So you have 0.699 plus, also this is plus, this is minus 0.477. So once we add this up, this will give us 1.176, and if you find the difference here, this will be 0.222. okay, and so we have 3x equal to, once we divide that up, that will give us 5.3. Yes, 5.3 when it is divided, and so x will give us 5.3 divided by 3, and that will give us a 1.766. So this is the result of the problem. Thank you guys. I see you in my next video. Please subscribe, like, and comment.